Hey, this is Pete Buchwald with Montreat College. I want to start doing a series. I'm going to be calling it Modular Synthesis Macros. And here's the idea. As I've gotten into this synthesis thing, I've noticed that on YouTube, a lot of people will either show one module and show some cool things you can do with it, some of the details of that one module, and sometimes I have that module and sometimes I don't, and it's often very interesting nonetheless. And the other end of the spectrum is that sometimes they will show some jumble of cables that looks like a plate full of spaghetti and some complex patch, and it's creating really cool sounds that I have no idea how to replicate. And what I want to kind of do is create a middle ground, a resource that offers ways to combine a handful of modules or a handful of common elements found in synthesizers in creative ways. And so these macros, these combinations of 2 or 3, maybe 4 elements and the way they interact, use those as building blocks and maybe combine. You can start kind of wrapping your brain around these macros and maybe even start combining the macros and have them interact. So I think this will be an interesting idea, an interesting study. Now, one of the cool things about being at Montreat College is we are very close to Asheville. And if there is a mecca in America for modular synthesis, for synthesis in general, it might be Asheville, with Moog music being here, as well as Make Noise, and a lot of startup companies. And it's my intention to not be the sole provider of content here, but to go out and interview other synthesizer users and to have them show us an idea for a macro using a handful of modules or synthesis elements that a lot of us have access to. So that's kind of the idea here. And maybe we can get to know them and what they do in synthesis and just kind of geek out with synthesizers a little bit. All right, well, let me tell you about the patch that I dreamed up. And here in Asheville, we have a synthesizer club, and we do these monthly jams. And I love that I went to one of these jams, and I brought this little red synthesizer here, this Behringer Neutron. And I was doing something that I had kind of thought up. And there's a guy there that's really good, and hopefully you'll meet him. But he after I heard what I did, I was so proud. Like, he came over and peeked over my shoulder to try to figure out what I was doing. And I know it should probably be an atmosphere of collaboration and sharing, but I was just so proud. I felt like kind of like I found a secret fishing spot. I didn't want to tell somebody. I kind of had a secret little patch that he couldn't figure out how to do. So I kind of want to hold on to that secret for a little while. But I'm going to show you how to create what he heard and was intrigued by. Okay. So here's the gist of the idea, and I'll show you on a whiteboard, and then I'll maybe demonstrate it on a synthesizer. I kind of took a deep dive into generative synthesis, meaning designing patches that evolve over time. There's a degree of randomness, and you kind of just let it run and create. It's evolving and doing things unexpectedly that you can't really control, and it's kind of fun. So as a part of that study, I try to think, how can I have my clock change over time? Because if that's driving things like sequencers and creating voltages that are going places, it would be nice if my clock, if I had the ability to kind of randomize the clock. And so as I consider that problem, let me show you what I came up with. All right, so here's what this patch is going to look like. Now we know that if we have a sequencer, here's my sequencer, we can drive that with a clock and get a consistent pulse, and that's kind of what we've always done. But what I figured out was that if you take an LFO or even an oscillator and a square wave in that oscillator, that square wave can function as a clock for that sequencer. So if we control our oscillator with a random voltage, then that gives us a random frequency going into our sequencer. So here's what that would look like. we would take our clock here, and at a slow interval, we would go into the hold of our sample and hold. Clock out to the hold. Then the output of our sample and hold would go to the control voltage of this oscillator. Tune down the oscillator pretty low as a starting spot. Then take the square wave out to the clock of our sequencer, and then the output of our sequencer would go into an oscillator and tell it which notes to play. So go with a slow tempo on our clock here, and sample and hold is going to choose random voltages for this LFO. LFO square wave can function as a clock, and it will get the sequencer going slow and then fast and slow, and it's pretty cool. A ton of ways you can complicate this and modify it creatively. The one way that something you might want to consider is inserting an attenuator before your oscillator, so that the range of tempos you can control a little bit. Sometimes if you don't want to go from hyper speed to super slow, you can kind of reduce that a little bit to your liking. So it's tempting to put some kind of attenuator in that spot. And yeah, so that's the basic thing, and ways you can use this and tweak it. It's limitless. So I'd love to hear what you come up with. All right, well, let's go over to the modular synthesizer and take a look and listen to this. All right, let me create this patch. So let's start with a sine wave. Okay. So first we're going to patch in from the sequencer. Go into the voltage control. Next, we'll connect a square wave, low frequency square wave. It's going to function as our clock. It's called a pulse wave on this one, but there it goes. So you can see we can change the frequency of that. Alright, so the next step is to randomize this voltage. So we're going to do that with sample and hold output. Next, we need to tell this how often to change voltages. So that's going to be clock into the hold in. Yeah, so that's the general idea. So that's just a building block, tons of ways you can tweak it, modify it, integrate that concept into other things. And so that's kind of a clock randomizer idea. Let me show you close up. I'm going to build the patch from the other side this time. So my clock output goes into the sample and hold. It's called hold in on this module. Then that's going to kind of grab a random frequency from the internal noise. And that random frequency goes to an oscillator. Oscillator is turned down a bit, and this oscillator is going to function as our clock. Square wave output on this one's labeled pulse. Then that pulse is going to go into the clock input for my sequencer. So that's our random voltages. And then the output of that sequencer goes to an oscillator, and that sine wave is going to our speakers. Now let's introduce an attenuator. So that would mean the random voltages coming out of the sample and hold we would want to control that before it goes to the oscillator. So that would be, go into this mixer, take the output of that mixer, then go into the volt per octave input. Then I should be able to narrow it with this in terms of this is narrowing the tempos. So it's a pretty consistent tempo. If I crank it all the way up, I should go from really slow to really fast. Yeah, so it's a broader range of voltages using that mixer knob as an attenuator. Okay, well I hope this is helpful and interesting, and we will see you guys next time.